Buckle up, everybody. Today, we're taking a deep dive into something pretty mind-blowing, Einstein's theory of relativity. So we've got this awesome science TV video all queued up. It explains how motion can actually mess with time and space. We're talking time dilation, length contraction, all that jazz, because the speed of light, well, it kind of plays by its own rules.
And those rules change. It kind of seems like science fiction at first, but the thing about Einstein's ideas is that experiments actually back them up.
That's constant for absolutely everyone. It doesn't matter how fast you're moving. If you're standing still or on a rocket ship hurtling through space,
Right.
you're going to measure the speed of light as exactly the same.
Every single time. Doesn't change.
So that means that the speed of light is like this unbreakable rule,
Yeah.
then something else has got to give, right?
Absolutely. And that something is our understanding of time. Time itself actually becomes flexible, but really it's relative to the observer. And this is what we call time dilation.
Okay, break it down for me. Time dilation.
So time dilation means that time actually slows down for things that are moving compared to, say, a stationary observer.
So, like, if I was on a spaceship flying super fast,
Yeah.
time would be moving slower for me than for someone back here chilling on Earth.
Exactly. And the science TV video, it talks about these experiments they did with atomic clocks.
Those are, like, super precise.
Oh, yeah. They measure time incredibly accurately. What they did was fly these atomic clocks around the world on airplanes.
Okay.
And then they compared them to the clocks that stayed on the ground. And guess what?
Well, tell me.
The clocks that were flying, they actually ticked just a tiny bit slower.
Whoa, really?
Yeah, exactly as Einstein predicted.
Mind officially blown. So this is like a real measurable thing. It makes you wonder, if we can stretch time like that,
Yeah.
what happens to distance?
Good question. That's where we get to length contraction.
All right, length contraction.
So when things move at super high speeds, they actually appear shorter in the direction of their motion.
Whoa.
Again, all from the viewpoint of a stationary observer.
So let's go back to those spaceships, one zooming past the other. It would actually look shorter to the ship that's standing still.
Precisely. And it all comes back to that constant speed of light, the length contraction of that moving spaceship. It's what allows both ships to measure light traveling at the same speed.
Even with the time dilation happening.
Exactly. It's like the universe is like constantly adjusting itself, all to keep that speed limit in place.
So basically, time and space, they aren't these fixed, unchanging things.
Yeah.
They're relative.
Exactly. Relative to the observer. Einstein, he actually combined those two, space and time, into this single concept called space-time. So picture it like a fabric, okay? And that fabric can be warped and stretched, by gravity, by motion, by all sorts of things. In the video, they use this example of driving a car. If you're driving 100 miles an hour going east, that's like your max speed. But you can also split that speed up to go, say, northeast. Now, some of your speed's going east and some's going north. And it's similar with space-time. We're all basically moving at the speed of light through space-time. When we're standing still, we're using all that speed to move through time. But once we start moving through space, we have to divert some of that speed.
Right.
And that's how time slows down for us.
So the faster we move through space,
Yeah,
the slower we move through time.
exactly.
Which means, okay, hear me out. If we could actually reach the speed of light, time would just stop completely.
That's one crazy implication. And then there's, going faster than light.
Ooh, even crazier.
Right. It opens up a whole other can of worms. Like, could you travel backwards in time? We just don't know.
It's wild, right? These concepts, they seem so abstract,
I know.
but they have real-world implications. I mean, obviously, we're not zipping around at the speed of light every day. But even though the effects of relativity are pretty small at the speeds we usually travel, understanding them, it changes our view of the universe.
Completely changes it. We have to accept that time and distance, they're not these absolute things. They depend on the observer.
Makes you realize that our everyday reality is just this tiny slice of what's really happening out there in the universe.
GPS.
GPS, what about it?
Those satellites orbiting Earth, they're moving fast enough that time dilation actually affects their clocks. Engineers have to account for that difference to make sure GPS is accurate.
That's amazing. Something as abstract as relativity actually impacts technology we use every single day.
It really is. It just shows how revolutionary Einstein's ideas were. Like, he didn't just change physics, he changed our understanding of reality itself.
So much to think about. I mean, if we could travel at the speed of light,
Right.
Would we experience time completely differently?
It's possible.
Could we actually travel through time? It's incredible. I feel like this deep dive has barely scratched the surface of all this.
Oh, yeah, just the tip of the iceberg. There's a whole universe of knowledge out there just waiting to be explored.
If you're as fascinated by Einstein's theories as we are, definitely go check out that Science TV video. Until next time.
See ya!